Hey everyone, with you Elena Litvinova, and today we continue to study TypeScript. I have on my channel previous lesson where we just started to study TypeScript, and we studied primitive types, object types, additional types like any, unknown, and void. Also, we have studied literal types, enums, and just only types. Interfaces, what is it and how it's possible to use them. In this lesson, I'm going to continue to study with you TypeScript, and in this lesson we will cover with you classes, how to create types for classes. We also will speak about the differences between implements and extends. We will cover generics. This is a really important part in TypeScript, and we also will speak about guard types, utility types like pick, omit, record, and etc. Well, I hope that this lesson will be really interesting. Before we start our video, not forget of course to subscribe on my channel, press bell icon, just not forget about new videos. Okay, then let's start. Okay, in previous lesson we have things like that. I mean, we cover primitives, just numbers, string, boolean types, begin, symbol, null, and defined, yes. Objects also, and arrays, yes. Tuples, additional types like any, unknown, void, and etc. Yes, literal types like that, and how we can simplify this with enums and types. Also interfaces, where we have some interfaces and even have extends from different interfaces, yes. And additional type like dynamic type when you subscribe to objects like that. Okay, in today's lessons, let's start from classes. TS. Okay, and how we can subscribe our class in TypeScript. Before we will start our classes, I'll prefer to comment everything, just not to have conflicts between files. Let's start from classes. How we can describe classes in TypeScript. If we, for example, go to documentation and go here and, for example, classes, we can find this information. We have a class, we have some, for example, class point, and we can subscribe which properties this class has, for example, like that, x, y, and they are both numbers. And let's try to create something and describe. Okay, let's create class user, and inside of it we will have name. We start describe our properties at the beginning of this class, and for example we can say this is string. Also we have surname, it's also string. And how we see already, TypeScript says property name has not initializer and it's not defined assigned in the constructor. How every one of you have to know that each class have to have constructor, which is called when we create new instance of this class. For example, we have user and we create new user and pass there some properties might be, or some variables which this user will about. For example, we can pass name, surname, birthday, and etc. etc. And these variables will pass there in constructor, and we can use the special object this, which is available in classes. Just save this information and use it inside this class in the future. Yes. Okay, cool. Let's try to create a user. Here we pass some properties, name, for example, Elena, surname, Litvinova. Who is this girl? Well, okay. We have name, surname, and here we have expected 0 arguments, but got 1 because TypeScript helps us everywhere, yes? Because we have not props here, we can you can call it plenty of different ways, and we have to describe these props. For example, name is string and surname is string as well. And be careful, here we have another object which is not compared with these types, and because of it we need to describe additional types, independent types, which is connected with these props but not with these props. For example, we can have here additional property birthday. I hope I have not mistake here, string, and for example by default we have something, yes, or we just I don't know, full name, have full name string, and we will create full name from name and surname, and we will create it in constructor like that. The props name props surname. It's not super right, there will not be a space here, but anyway, yes. Well, there is a mistake here. And I just wanted to say that these types is different with these types. And because of it, yes, just cancel everything. And we need to describe this object. Okay, we have name. If for example I add something additional, we can see that TypeScript help us. Oh no, this is wrong because arguments of type this is not assignable to this, which props need, because we remove it. Okay, and after it we can pass name and say props name. And how we can see this highlight is disappear. After it we have this surname and for example props surname. Well, and this highlight disappear as well. And currently our class and his implementation is fully correct with TypeScript, and we can pass types like that. Also, if we add here exclamation mark, it will mean that we not need to describe this property. There is no highlight anymore. Yeah, you see. And this is an additional thing which we can use in classes. What we also can use in classes, there are some different additional properties which we can use. It is private, public, and protected words. For example, we have public methods and public properties. For example, name is public property by default, and all methods which we have here, for example, print full name. Let's add additional method and just say console.log this name space this surname. And what we can see, this name, this surname, space, print full name. And we can use, for example, we have created already user instance, and we can use ask name, for example, yes, and we can print it, use it, and we will give name Elena in this example. We can also use ask surname, birthday, and also we can print name and call it, yes. But for example, if this property is private, it means that if I try to ask this property, I will have TypeScript will say me, sorry, property name is private and only accessible within class user. Yes, there is another word, protected. When you try to ask this property outside, it's also say it's protected and only accessible within class and its subclasses. And this is difference between private and protected. Private means that this property we can use only inside this class. Protected means that if, for example, we have class customer and we extends this class from user. Extends means that we inherit all properties and methods from the parent class, and we can use it in customer. Yes, but before we have to start constructor, and in constructor we have to call super. This is special method which is called our parent class, and here we have to pass the same things, I mean needed props for parent class, like that. Hop, and yeah. And for example, when we will create customer, not user, yes, we already pass name and surname, and for example customer have bill, and also we can pass bill number, and here bill, well, and after it we have to say bill is props bill. Well, and after it we will be able to use customer and ask, for example, print full name, yes, and we have this method. This method will print for us name and surname, and also we can, inside of this class customer, we can use super name. This special word super help us to ask properties and methods from parent class. And we also can use this, but for example, if we have additional name on the same method or the same property in this class, of course, this property will be more important and it will used. I mean, for example, if we have our own name here, and we will pass the name here, then this name is more important, props. And if we want to get name from parent class, we have to use super. Okay, and for example, here we can use super name and we can use protected property. It means a protected property we can use inside own class and all inside of additional classes. For example, customer name. No. We will return name from this, and we can see that within class user and its subclasses. Yeah, I hope you understood this part. This is super easy. Okay, what also we can do with classes? I will not cover everything about classes, just some information about types. We can add interface, for example, interface user, and subscribe what class can have. For example, name, string, surname, string, and for example, method, print full name, which will return void, something like that. What we can do with interfaces, we can implement this interface. We can't extend it because difference between extends and implements. Extends help us inherit methods and properties from parent class, for example, or if we extends interfaces to inherit previous properties from interfaces. Implements, it just means that you have to describe these properties and methods inside of your class, but you not have it yet. Yes, you're not inherited. It is difference, and we can extends, implements implements user interface. What it means, we have class user, property name is protected. Yeah, here we can actually remove everything. I mean, really remove everything of it. Oh no, we can't remove. This is actually interesting because when I started to try interfaces, I thought that, oh, might be I don't need to describe again this property and be free from it, but not. Implement this interface, but anyway, you have to say inside of it that this string as well. And okay, we pass it here. If you are not, we have a mistake and error. This is interesting. But at the same time, if we not describe method, we can see helpful for us that property print full name is missing in type user but required in type iUser. Yeah, really interesting. And I cannot forget this method. And interfaces helps us not forget something, yeah, and also to show what we have inside of this class. It's really helpful. Inside of class, we also can pass some properties, additional name, and say that it's a string, and we can return, say, for example, undefined, or we can return string. Just described this function better. And of course, if we implement any interface, we have to have the same things here, string. There is an error because we not return string. Now there is no error. Well, if we, for example, not pass it, it's also we have to say that this string. Yes. Well, looks like that. And for example, we can add additional name here. Yes. And use it somehow. And when we call this function, we can see that TypeScript help us. We need additional name, which is string. Well, this information what I wanted to discuss about classes. If you, of course, want to study more, you can just continue with documentation. I think that this is the most important thing, but there are also some interesting things about get, set, but it's mostly about classes as well. Okay, let's go next. Next, we have extends and implements differences, yes? Extends and implements TypeScript. Let's try to understand where we have differences here. How we could see before, in classes, we used extends and implements for interface and extends for class. Extends means that we extend parent class. Extends. Sorry, I'm not super native speaker and sometimes slightly lost. Okay, we have a class and we want to extend this class with another one, with method and properties from another one. And for example, if we use first class extends from other class, it means that we will have these properties. Implements, it means that we will not have these properties. We just say, we have this class, for example, this class implements interface, and it means that inside this class we have to have these properties, but we not have them. We not inherit them, yes? Okay, let's try to check what we can implement, extends, and how much interfaces, classes we can do. For example, we have class user, yes, and we already have class user. Okay, I just comment this. We have class user, and we have class customer. Class customer. And we can say extends user. Our customer extends of user, yeah? For example, if we have two classes, user and user one, yes? Can we do extends from two classes? Just let's check. No, we can't. Classes can only extend a single class. This is important. We can extend only one class. And let's write here. What is about interfaces? For example, we have interface iUser. Okay, I don't know, name for example, yeah. And we have interface second user also with name. For example, surname, yeah. And we have class customer2, which is implements interface from user 1, yes. And it means that we of course need to pass here name, string, and in constructor we have to say that we have name, but we can put an exclamation mark, and we don't need to describe the constructor. Well, and we've just implemented first interface. Could we implement another interface, for example, using comma? Yes, we can. We just need to add surname, and yes, we can. It means that we can implement a lot of interfaces how we want. We can implement infinity count of interfaces. It's just not only one. There is also interesting thing. We can implement classes. For example, we have class user2 and user3, and we have class customer3, and we can implement user2 and user3. What means implements class, not extends? It means that we just want to say this customer class, that this customer have to have the same properties and methods which there are in user2 and user3, and we need to describe it there. For example, we have here name string, yes, and don't know, will it work like that? And we can hover incorrectly implements user2. Did you mean to extend user2, or property name is missing? And we have to say string. Then everything is okay. We implement it. It's the same might be with like interfaces, but we implement classes. Okay, let's add additional sentence 3. We can implement infinity amount of classes. This is third. Let's look on interfaces. For example, I have actually I can, you know what, just comment it, and I will be able to use the same naming. For example, I have interface user, and I have interface user2, and I can say extends iUser, yes. And what it means, for example, if I create an object which have interface like that, I have to put in this object and name and surname. We extends iUser2 with iUser. It means that in object we have to have the both. Can we implement, for example? No, we can't. We can't implement interfaces, unfortunately. What we can say here, let's check, can we extend a lot of different interfaces? For example, here we have birthday. Okay, use comma. Yes, we can implement a lot of extends a lot of interfaces, and after it we have name, surname, and birthday. And how we can see, everything is right. And fourth, we can extend infinity amount of interfaces for interfaces, yes, and we can't implements interface can't implement another interface. Yep, interface can extend infinity of amount of interfaces of other interfaces. Yeah, it sounds much better. Class can implement class. Well, and this is difference. This is different between extends, implements, and now we understand what we can do, what we can't do. And sometimes it could be asked on interviews, because remember it. Okay, go next. Next, what I want to speak about, it is generics. Generics is really a super important part in TypeScript. This is 10 generics tests. Let's start maybe with documentation. Generics. Go here. What we can see. Hello world of generics. Well, generics help us to describe type which we don't know yet. For example, we have function identity, and we using the special symbols here, like that we can say our function that this is generic. We can say after it we can use this type inside of arguments, this function, for example, with a return type, or inside of this function as well. For example, let my variable have type, yes. You can use different naming, for example, just letter or base, how you want, but of course after it you have to repeat it. And it means that here we don't know this type, but when we call this function we have to say which type we want to provide, like base. For example, it could be string, yes, and it means that like argument we have to pass any string. When we call this function we provide the type which we want. And this is about generics. It's really helpful in a lot of different functions which we can use in TypeScript. And for example, we have a function make request. Inside of this function we have URL, which is string, yes, and for example some options. And let's create interface, options. And here, for example, we have query string, yeah, and we pass this option here, and it have to return us something, because it is we have function make request. It is like a global function. With this function we can ask server with different information. For example, we can pass URL get users and it have to return us users, or we can pass here articles and this function have to return us articles. And when we create this function we don't know what was returned. And for example, there are a lot of code here and I want to ask users, and I write make request, and for query I would not require it. And here I just pass first argument URL get users, and after it I want to have here users, and I have special interface for users. I know how they looks like user. It have name string and surname string, yeah. And I want to, these users will be with the same interface. It means something like that, user array, yes. But how to say this function that it return our users? I can say, okay, it return user array. Yeah. And it make request. I need to pass options, just empty object, because query is not required. And for example, I have to return here an array with any user, just because function asked me. Surname. And now it works. I hover on users, yes, users. But if I want to have articles, and I have another URL, articles, and I don't want to have here users, yes? I have another interface, article. And it's totally different interface. Title, for example, string, yes? Author, string, and content, string. And this is something else. And when I hover on articles, I want to have hover. And here I can use generics. For example, I can say that here I want to return users, and I just pass user. And here I want to have article type. And how I can describe it, I can say we have T here. It's like short from type. I suggest, I'm not sure. And I can say that this function return type array, yes? But at the same time, might be it could be not array. For example, I ask just one user, yeah? And because of it, I can provide the full type. For example, user array, and just say that it return this type. And what I can, for example, do here, after it I ask server with this information and just return this type. I can say for now, just because we have no server, say that this is any array as them. It means that I say TypeScript, I'm more clever than you, and I know that this array have this type. In current situation, it's not super good to use it, but I just want to exclude mistakes and to show you how it works. Well, and after it, when I hover on users, I have, yes, it is user array. If I hover on articles, I see that, yes, it have article array. And of course, inside of this function, we have to be sure that we return article type or user type. But anyway, we can use generics this way. What also possible to do with generics? We can pass a lot of arguments here. We just need to use comma. For example, I can have here request type, options type, return type. Okay, I left this function and create a new one. For example, identity 2, URL, and I don't know. What I can do with generics, I can pass several types, a lot, T, I, K. It's better to call somehow better way, but actually on practice usually you can use just T, like a short naming. But if you have a lot of different generics, you can create more understandable naming. And for example here, options type, return type, yes? And after it I can use it. For example, for return type I have this, options I have this, and I have return something with this type. After it I can call this function, and of course I have to pass here option type, for example string, and return type number. I can pass there everything what I want. It could be enum type, and after it on options I need to have a string, yeah, and after it have to return number, and it will. SSS is number type, but actually it's not number. We see the dangers of using this thing, but anyway, we can be super we just can to say TypeScript, I'm sure that this array, it's not array, it's number. Be careful with these arguments, but sometimes it's really neat. Anyway, we can use generics like that. Also, we can use generics with interfaces. For example, I have interface test, and I can pass generic here, and my test interface has type property, which will have type, which we pass there. After it, we have name, string, and other properties, for example. And if I create an object with test interface, I have to pass here which T generic we have here, for example, string, yes? And after it, when I create this interface, I have to pass type string and name string. Yes, and how we can see, I already have this object, and how we can see, we can use it like that. Or for example, I can pass here number, and after it I have to have here number. We can use generic with interfaces. Also, we can use generic with classes, interfaces. If, for example, classes, we have a class, my super class, I also put generic here, and I can say that name is type, which is depend on this generic, yes? And constructor, we have name, which is the same type, and this name is equal name. After it, when I create an instance of this class, my super class, new, I create instance, I have to pass which type of name I want to have, number, for example. And after it, I have to pass number here, because we have the same type, or string. We can use generics in classes like that. Of course, we can pass a lot of different properties which we don't know, but we have to describe them when we call this class. And of course, we can create a lot of different instances and can pass different generics here, different types here, and it will works. Yeah. Also, for example, if we want something by default, function calculate length. For example, we have a type here, and inside we have arguments here, which is them, and we return number. And we have to say return let's args, return args length, return no. But TypeScript says, sorry, we have the type T and this type has not length. And what we can do, we can use extends. Extends, let's call extends and default. For example, interface mean user mean function info, and we have interface, we can say length here, number, and we say this type extends of mean function info. Yes, and we see that now we can return this length, and when we call calculate, we have to pass this tab, which is we have to have length inside. Props we say this props, for example, don't know, name, string, yes. We have to have here number. And of course we have to pass name, string, and length. Length. We also cannot have it here, but no, props doesn't satisfy me. Okay, yes, we have to pass here length, a number. If we try string, yes, it will shout again number. Well, okay, and we always have to call this function with mean param, which is length. Yes, and for example, if we have something by default, for example, we have interface, something by default for this type, we can use default calculate. For example, we have name string, and by default we have this. Of course we have to have length, yes, and we cannot pass this type. We just, by default, we have name and we have to provide it, or just length. It's interesting. Well, looks like that how we can work with generic types. Okay, we can continue and go to type guards. Create a file, 11, TypeScript, yes. What we can have here, what is type guards? We have, I just tried to comment everything here, just to exclude any conflict with users, a lot of users, yes. Okay, for example, we have interface user, just name, string. Also, we have three interfaces, interface human, here we can have speak, we can have just void, just for example, or we also have here cat, we just can say meow, and we can have a user dog, which bark, and all of this interface extends user. Extends user. It means that when we use human interface, cat and dog, we of course need to pass name. And after it we have, for example, from server, we receive some information. We have name, Mir, and this is a cat. And inside we have console.log, meow. Yes, this is cat. And we just only know that this is user, but we don't know which user it is. And we can check it with type guards. For example, we can create a function. Is it a cat? Is cat. Inside of it we have info, server info, this is user, and we want to check that this information is cat. And after it, when we check it, for example, if is cat, we will be able to call where is server data is cat, we will be able to call meow without mistake here. But we need to write this function isCat, which is type guard. It will return server info isCat issue. Yeah. Inside of it, we have to make a check. we can to say return if we have, for example, type of server info me of is equal function, just boolean value, and if it's true we have me of function, it means that this is cat. But we have showed here this information have not, the user have not me of, and we can say here TypeScript use this param as and say that we suggest that this is cat and this has me of, and we just check this is function or undefined, for example. We just with this information we said say TypeScript, we assure that server info is it cat, but at the same time we just suggest that this is cat and cat have to have me of function, and we check and we return that server info is cat, and after it we can call me of method without any highlight. This is type guards, and we can create a lot of function, for example is cat, is dog, is human, and use this server information in our code. Okay, go next. Next is utility type. This is 12. What is utility types? For example, we have interface accommodation, title string, location string, address string, count of rooms, not required, number. Utility types. Let's look which utility types we could have. Utility types. There are a lot of them, of course, and you can look at documentation, but we just can check several super interesting. For example, we want to create object which has a type accommodation, but it has only title and location. And we can use the special utility type pick, put accommodation here, and after it say what we want to pick. Title, for example, and address. And after it, when we will create this object, we have to subscribe title and address, and that's it. Yeah, you see there is no mistakes. There is opposite utility type omit. It means that we exclude title and address. It means that we have to pass everything else. Count of rooms is not required because we cannot pass it here. But object 2. Yeah, and how we can see, we can use like that. We also can pass count of rooms 1, yes, but if we put it here, there is a highlight, yeah. This is omit. What also we can do with this? For example, let's look on arrays. We know that when we create an array, we have number array, yes, and we can say 1, 2, 3. But we also can create array with like that, array, and here is type. If you go to this function, it looks like array, and inside we have generic, yes, and we can pass here everything what we want. Also we can use read-only array. What it means that after it we cannot change somehow this array. Yeah, we just can make map, for example, everything which doesn't change this array. Find information and etc., but we can't change. If we have just only array, we can. Well, what also we can do, for example, we have object 3, continue with these things. We can use required utility and say that each property inside which we have in this object is required. It means that we have to pass everything what this interface has. Yes, if we forget counter rooms, it also will shout because everything started be required. Also, there is additional type for partial. It says us that each property is not required. Yeah, but we can't put something additional. We can use everything, all properties from accommodation, but all properties started being not required. Just it is about partial. Also, let's look on interesting utility, which is record. Now, we studied with you on previous lesson dynamic types, and there is a special utility record which help us have something the same, but more dynamic even. Okay, let's look what record could help us. For example, we have interface cat info. Inside we have age, number, and a color string. And we have type cat name, which could be Miffy, Boris, enough, Miffy and Boris. And we can create an object cats which will have record, utility, and like a key in this array, it will use cat name, like information about by the key, it will have cat info. And how we have to subscribe this object? Cat name, it means that here we have to have Muffy, yes, and information, age, number 1, color black. And also we have to pass Boris because we have Miffy and Boris. And if we pass Boris as well, there is no mistakes anymore. What we just done here, we create cats with types which we can provide here. We also can use enums, for example, it also will works. And here we can pass enums like that. In square brackets we can pass enums, for example, if we have type const enum, cat name enum, for example, Miffy and Miffy, Boris, we don't need this here, and we just can pass enum here, and after it we use something like that, Miffy and this one, yeah. Well, and here we have interface from second argument, and this one. If we try to add something else, we will have a mistake. Really useful property which you can use and play with it, and yes, this is really super interesting. I hope that this video was helpful for you, and I believe that after this video your knowledge has started to be more strong and you will be able to continue to use documentation and to use TypeScript in your projects. If you have any question, just write comments after this video. Also, I put all this code about TypeScript dive in my GitHub account, and I provide a link in description for this video, and you will always just go to GitHub and just look and remember, yes, everything. And of course, not forget to subscribe on my channel, press like button, bell icon, and see you in next video with your Elena Litvinova. Bye bye.